Hi, welcome to our chapter on Earth science. Let's cover some topographic maps, and I just kind of want to go over what we're going to be doing in this week's lab. Um, the first couple of pages are just kind of a background of what is a topographic map, how do we interpret data on a topographic map, and then the last couple of pages are the pages you're going to turn in. It'll state, turn this part in. Part you're supposed to turn in. So what we're going to be looking at are topographic maps. Now, a topographic map, quite simply, is a map that shows the landscape. It is a three-dimensional surface represented onto two-dimensional piece of paper. And so by the end of this chapter, or the end of this lab, we're going to be understanding how to make contour lines, understanding things like gradients. Just like in a math class, it's the rise over the run. We're going to look at things like relief and different map scales, and you're going to be able to make a profile or a side view of of a map. So here are some of the key terms. The bar scale is that little bar that you'd see on the bottom of a scale that you can use to measure. Google Maps uses a bar scale, and it just says this is how far that is. And so that's a great scale to use. A contour line is one of the words that we're going to be using a lot. It simply states the line at which all points on that contour are the same elevation. Obviously, a lot of that information is implied or approximated using some data. But if we ever want to go through and physically go down and figure out the altitude at one spot, we'd mark a benchmark, a clearly known spot. Now, when we start looking at topographic maps, you'll see a bunch of different squiggles on these maps, and I'll get to those squiggles here in just a second. But what are you counting by is the contour interval. A different type of scale that we can use is something called a ratio scale, also called a fractional scale. It's how big is the map in compared to that same distance in real life. The equator is the bisector of the Earth halfway between the North Pole and the South Pole. The equator is going to be really important because when we start looking at latitude, it's how far off of the equator we are. If we were to draw slice the Earth in half and draw a line from the equator to the center of the Earth, and then come back out to any surface on the Earth, that is that angle that we're measuring is actually our latitude. I've already mentioned the gradient is the rise over the run. We'll look at that. Hash marks are little negative signs that tell us that we're going down as opposed to up on a contour line. Not every contour line is labeled. And as a result, we'll have the index contour, which tells us usually every fifth contour line is labeled, and that's the index contour. Latitude are these horizontal lines on a globe. Longitude are the lines that go from north and south of from the North Pole to the South Pole and are measured off of the prime meridian. A relief is a tool that's talking about the difference between the high and the low point on a map. A profile is a side view of the Earth. A verbal scale is a third type of scale that we've looked at, is going to be telling us 1 inch on the map equals so many feet in real life. And so that's a verbal scale. And then finally, vertical exaggeration. When we're dealing with topographic profiles, we can exaggerate or extend the y-axis and compared to the x-axis and make it stretched out or exaggerated. So if you're not familiar with a longitude and latitude, here are the longitude and latitude lines as described there. But the main focus of our class in our lab this week is going to be dealing with these topographic maps. And here's an example of a topographic map. And these are lines connecting equal elevation. I'm going to zoom in to really show off these different lines. And so we can see that this line right here is the 5200 line. And so that tells us that everything on that line is exactly 5,200 feet above sea level. So our data measuring starting point is sea level. And we can see that this line right here is 5,600 feet above sea level. And this one is 6,000 feet above sea level. Each one of these that are labeled are our contour intervals. Excuse me, our contour, excuse me. Each one of those, I want to make sure I get my terms right here. Each one of these is a index contour, a contour that is labeled. What we're counting by, you'll notice that some of those lines aren't labeled. And so if we start looking at this line right here is the 5,000 foot contour interval, and this is 5,200. And these ones in between, which are not as dark, they're still contour lines. They're just not labeled. But we know that if there are 5 of these lines in between a span of 200 feet, 5 divided by 200. So that means that each one of these intervals or each one of these contour lines are going up by 40. So the contour interval of this map is 40. So a lot of times these maps are broken down into smaller sections or quadrants. And a lot of times these are either 15 minutes. A minute is 1/60th of a degree. And so when we start looking at these different scales of maps, we can actually look at different what levels of zoom we're going to be dealing with. So we've already mentioned what a contour interval is, what we're going up by. The gradient, again, is the rise over the run. So let's scroll down. To the practice questions. Again, these are not to be turned in. The last portion of the page is going to be turning in. Now, as rivers start to erode, they will actually notch out and lower the elevation. And so this river here is actually carving this material and actually causing the contour line to create this V shape. And the V's, the contour V's, this is called the rule of V's with contour lines. The contour V's always point uphill. Now, the contour interval on this map is 70 feet. And so this line right here is 70 feet, which means that this line right here would be 75. The V always points uphill. So if you had an elevation of 75 and an elevation of 70, we know that the water would flow from the 75 to the 70. And so in this case, the water would be flowing south. Now, to find the highest elevation on the map, this is a little tricky because not every line is going to be labeled. But if we know that this is 70, this line would be 75. And I would encourage you to, if you have the ability to print out, or you can add this image into something like Notability. So here's the image that is in your lab, and it shows that 70-foot contour line. So I know that I know, pause this, that my contour interval is 5 feet. And so if this is 70, that means that this should be 75 feet. And then this would be 65 feet. Water flows from the highs to the lows. And so in this case, the water would be flowing to the south. Um, Again, I can count, if I know that this is 70, that means that this would be 80, 85, 90, 95. So the highest elevation here would be right in the middle here, which would be higher than 95, but less than 100. So I know my high elevation here is, I'm going to call it 95 to 100. And the low elevation, well, we know that water flows downhill, so the water would flow down. And so down here would be the low spot, somewhere between 60 and 65. So the result would be about 35 feet of elevation. So the relief of this map would be 35 feet of elevation. Now, the second portion of the map, or of this lab, is going to be drawing in your own contour lines. I'm going to actually switch markers here. And this isn't your lab. This is a very similar lab to what you have. And it shows it has a stream there. So what I'm going to do is try to figure out what my contour interval should be. Now, in my case, um, my exercise has 100 and a 500 over here. So I probably only want to do a 800. So I'm going to have to do a contour interval of about 100. If I did a contour interval of 1, it would work, but I just have too many lines on here. So when drawing in a contour line, what I would recommend is trying to figure out what elevation what contour interval would work well for the map that you have and the data points that you have. And again, I'm going with 500. And so I have a dot right here of 500. So I know that that dot is right on my contour line of 500. In between 505 and 350, I have a dot here that's going to be 500. Because if I was going from 350 to 505, I'm going to hit 505. Now your dot may be a little bit closer over here. Mine might be over here. I don't have enough data to tell me one is wrong and the other is right. So then I would connect lines of equal elevation. And so my 500 would be in between the 600 and 400. Now there's in between 600 and 650. I cannot, I'm never going to hit 500. So my 500 contour line can't go in between there. And again, this map would either run off the page. Now, I know that contour lines have rules of V, so that means that my contour line would actually make a V above off of the page. And these are easy to grade because my contour line of 500 is always going to have one side of the page that's less than 500. One side of the line is going to be greater than 500. If that line wraps around, we can see that it is, in fact, this is the positive side, this is the negative side. Every one of my dots are going to hold true to my line of 500. My next line is going to be my 600 line. Oh, I've got two 600, so I'm going to connect those two. 600, 600, 600. And again, this would wrap off the page here. And I could do my 400. You'll notice that my line may get close, but it's never going to cross. Because if it crossed, where at that point you'd say that you had two elevations. Now again, everything on one side is greater than 400. Everything on the other side is less than 400. My 300 contour line be something like this. My 200 contour line my 700-foot contour line Now, I can see this is why you'd want to use pencil on this, because up here, I have 600 and I've got some 500 over here. So that means that my 600 line here needs to get adjusted. Now you may say, why that looks awfully weird. And I agree it does, but that's what the contour lines tell us. And so this is my 600-foot contour line. My 500-foot contour line would also wrap back up through here. My 400 would wrap around. Looks kind of like a ridge is developing over here. So this is 600. My next contour line would be my 700. Again, this is my only 700 dot. Everything on the inside of that circle is going to be greater than 700. Everything on the outside is going to be less than 700. My 800. Let me label these. 800, 700. 600 is labeled. 500 is labeled. 400 needs to be labeled. 300. 200. And my final contour line is my 100-foot contour line. So now every point on this map is going to be identified. You're going to be doing a very similar one with this image right here. Now, the next thing that you're going to be doing in this lab is a topographic profile, a side view. And to do this, what we're going to do is you take let me zoom in so we can really see this one. Sorry about that. Sensitive here. So if we take a look at this image here, we have the 300-foot contour line. So if we were to walk in a line right from the left of the screen to the right of the screen, what would we cross? Well, at 300, we would draw a line straight down and put a dot in. And that 300 would tell us that that's what the elevation is. Then at 320, 340, 360, 380, 400, and then we'd hit 400 again. And so if we were to go right along that line, draw a line right in there, you'll notice that every time that we're dropping down, what we're doing is we're making a side view, what it would look like from the side. And so this 300, straight down to the 300. And so what you're going to be doing is the exact same thing from A to A prime. So the first thing I would do would be to label these elevations. Now we know that this is 800 and this is 900. And so we know that there are 5 lines in between. So each one of these would be interval of 20. So the next line would be 820. And so what I would do, move my screen down ever so slightly, try to fit this both on the same page. You'll notice that, so on my 800 line, or my 900 line, I can do that one nice and easily on this screen. It's right there. I would go straight down and put a dot. My 900 line, straight down and write a dot. And I would do the same thing over here. And again, we have a ruler. If you'd like to print this off, my 800 make this a little bit smaller. Wherever the profile is, go straight down and put a dot. And so what you're going to end up with is a bunch of dots that are going to give you the profile, the shape, whatever shape that is, whether it's going up or going down. And so that's how you're going to make the profile by using the intersection between the line and whatever that elevation is. And you're plotting out what that is. So the part that you're going to be turning in this lab is starting on page 14 here. You're going to be labeling these elevations. Notice that the shoreline and elevation of the ocean is going to have an elevation of 0. And then you're going to move off of that 0. These little hash marks are telling us you're going back down. Then you're going to turn in page 15. And again, grab images, print it off. I don't care how we get the data. I just want the data. Then you're going to be drawing in a contour interval there and drawing in those contour lines. And then what is the contour interval of this map? What is the relief of that map? What is the gradient? The gradient is the rise, change in elevation, divided by the run, the change in the length. And again, the elevation tells us the change in elevation. Well, the contour lines tell us the change in elevation from point A to point B. And so in this case, if I was going from 210 to 95, that would be an elevation change of 115 feet. If I measured the bar, if I had a scale on this map, I could figure out the distance in between. That would be the horizontal distance. And so then I could calculate the gradient, which would be the rise divided by the length or the run. So that's the portion you'll be turning in for today, for this week's lab. Let me know if you have any questions.